negative infinity to negative 3, and then 5 to infinity. How would that change if I wrote x minus 2 squared times x plus 3 times x minus 5 is greater than or equal to 0? What's that? So I would change some of my parentheses to brackets, first of all. Like this I would write as negative infinity to negative 3 like this, because negative 3 is a 0, okay? And then there's not a interval here, but where else, this is equal to 0, so I have to include it in my answer, right? So we just write this like this, okay, at 2, and then 5 to infinity, but I'm including the 5. Question, Hayden?
I was just wondering why you did that.
Okay, because I changed this now to greater than or equal to, and so I have to include the spots where it's 0. So this means, if I were to write this, this means x is less than or equal to negative 3 as opposed to x is less than negative 3. So if you'd like to write it that way, that's fine. Yeah?
Would the 2 have to be in brackets too?
Would you like that better? It's just telling me 2. It's just saying the number 2. It's not the parenthesis business where it's a less than. So I'll put it in the squiggly bracket, just so you understand that doesn't mean 2 to 2 or anything like that. Okay? All right, so then let's do x minus 2 squared, x plus 3, x minus 5 is less than 0. So what would you write for this? Negative 3 to 2, and then 2 to 5. I don't include the 2 because this is asking where the function is less than 0, and at 2 it is equal to 0. So that's why I write them in parentheses there, not because there's an asymptote or anything like that. Okay. And lastly, let's solve the inequality x minus 2 squared, x plus 3, x minus 5 is less than or equal to 0. And so how would I write that? Now, because the 2 is included, I can go all the way through. So I can write negative 3 to 5, and I include them. Okay. So at this point, if you prefer to use inequalities, that is up to you. Then anything that had a parentheses, those are less than or greater than symbols, and something that would have a bracket would be less than or equal to or greater than or equal to, and that is okay. But that's how we write things in interval notation. So what if I didn't have a graph to look at? And I know that you have your graphing calculators, but in courses that you would take further on, you would need to just kind of be able to know when it's positive and negative, and so we make this thing called a sign chart. Have you guys done sign charts before? No, you don't think so? So what I'm going to do is for this next example, and by the way, if you're using a sign chart, it does have to be in factored form. So either I would give the polynomial to you in factored form, or I would ask you to use techniques that you know already to factor it. So let's say I gave you this function, f of x equals x minus 1 squared times x minus 7 times 3x plus 5. First, what we're going to do is we're going to make a sign chart. So I'm going to show you how that works. Okay, so a sign chart, what you're going to do, and tomorrow this is going to be different because that's why we're doing polynomials today. Polynomials for a sign chart, the things that go on the sign chart are the zeros, and the reason we put them on is because what could happen at a zero? What could happen to the sign of the function at 0? It could change. And so what we do is that we just look at what happens in between those zeros. So we find the zeros, and in factored form, hopefully that becomes pretty easy. What are the zeros of this polynomial? Okay, so 1, 7, and then if I were to find 3x plus 5 equals 0, wouldn't I subtract 5 and divide by 3? So that would be negative 5/3. I'm going to write it this way just so you understand where it is numerically. That's negative 1 2/3, right? Okay. Now, your sign chart, you should just then kind of make a number line, and you're going to put these things on, and you don't have to do a scale or anything. You're just going to leave some space in between and put the zeros on from left to right. What's the first zero that occurs from the left? Negative, I'll write it 1 2/3. So this is a 0. And then next would come 1, right? And then I'd put 7. That's also 0. Should extend it. Okay. And so what we do then is we pick numbers that are easy to work with, and we plug them into the function, and we just see what kind of number I would get. Okay, so let's pick something to the left of negative 1 2/3. How about negative 2? That's pretty easy to work with, right? All right, now all I want is positive negative here. If I pick negative 2 and I put it into this first function, and then I squared it, what kind of number would that be? Okay, so it would be positive times, I'm writing positive because what would that be if I put negative 2 in? Positive or negative? And if I put negative 2 in, what would this be? A negative number, agreed? Okay. What if I put negative 2 in for here? What would that be? A negative number, correct? Okay, so then you tell me, what's a positive times a negative times a negative? Is it going to be positive or negative? So I'm going to put, and I'm going to circle positive, and then that tells me without looking at the graph, I know that to the left of negative 1 2/3, the function is positive. What's that? It is cool. Now, I always like to pick 0 if I can, and do you see how the number 0 occurs between negative 1 2/3 and 1? So let's pick 0 for our second one. If I put, well, first of all, wait a second. If I square anything, isn't it going to be positive? Okay. So if I put 0 in, that's going to be positive. How about when I put 0 in here? Negative. How about if I put 0 in here? Positive. So a positive number times a negative number times a positive is negative. All right. Now let's pick something between 1 and 7. 5. Sure. Can you pick, guess what? If you pick 2 and I pick 5, we're going to get the same result. Because we're only looking at the sign. We're not looking at what the value is of the function. So if I put 5 into the first thing, it's going to be positive. How about here? Ooh, so there wasn't a sign change here. Hey, doesn't that make sense because this is an even multiplicity? Oh, it does. Okay. Now let's pick something to the right of 7. 8, okay. What if I put 8 in the first thing? Fine, 10, positive. 10 minus 7 is going to be positive. 3 times 10, all right. So even though I don't have a sketch of the graph, I can then answer any kind of question. So if I then went one step further and said, hey, when is x minus 1 squared times x minus 7 times 3x plus 5 greater than 0? Let's look at the sign chart and we're going to give our intervals. Greater than 0 means what? Another name for that. Positive. Okay. What would you tell me then? Well, right here, how would I describe that interval? Negative infinity to negative 1 2/3. Or you could write x is less than negative 1 2/3 if you want. And where else? And couldn't you also even give, I'm not going to ask you to do that right now, but couldn't you also even sketch kind of what the graph looks like from that? Like just, you could say, oh, it's positive, then it goes negative, and then it comes back up again, stays negative. Okay. So, especially, I know some of you, this is going to be the highest you go in math, but we use sign charts a lot in courses beyond Precalculus. Like in AP Calculus or any calculus class you would take, we use them a lot to just describe without graphing what functions look like. All right, good. So, take out your books.